and we can get going. Cool. Today we want to look at graph visualization. Graph visualization is a really cool topic because that's one of the really fun sides of graph databases, which give us the opportunity to create these really nice circle and arrow or other kinds of graph visualization where you can, chase nodes around and things like that. So people have a lot of fun doing that. And actually, it's not hard to do it. And I want to show you a library that I've used in the past, which I really like because it's very, very well thought through. And I really like how they approach this. So Neo4j as a graph database has all the data already in a shape of nodes and relationships. So it should be pretty straightforward for us to get the data and provide it to the graph visualization library and visualize it there. So for us, we want to use today the Game of Thrones graph visualization, the Game of Thrones dataset, which is basically from the books. It's coming from a mathematician called Andrew Beveridge. He did a study called Network of Thrones. Where they basically analyzed the books and created relationships between protagonists where the distance between them in the text was below, I think, 15 words or something like that. So every time someone, spoke about someone, killed someone, married someone, talked about someone, it created a relationship between them. So we have kind of an interaction network from that. And we have all this data in our demo database, so you can just go to demo.neo4jlabs.com/7473 and use the username and password Game of Thrones. And then you should see the Game of Thrones database that you can also play around with. And that's what we want to use today, both for the library but also for the React application. Okay, let's get started. So we just get started with this here. So I basically have a repository called Neo4j 3D force graph. It's on GitHub. And I just played around kind of combining this 3D force graph library with Neo4j. And I just wanted to show you how this works. And the library itself that we're basing these things on is also on GitHub. And interestingly, it has a 3D variant which uses WebGL, so it's quite performant. And with a ton of configuration options, we'll get into that. But also 2D versions, VR and AR versions. So if you're into VR or AR, you can look into this. And also React bindings, which we'll look at later. So we'll look at the 3D one first as a quick starter, and then we look at the React ones for 2D later. But if you want to use it just out of the box with your own stuff, then it's pretty straightforward to use, as you'll see in a minute. And so here's the direct React one, and here's the 2D one. But our repository that I have over here basically takes the library and shows some of the examples in here with some example code that I want to show you really quick. I also wrote this up on Medium. So if you go to medium.com Neo4j, we have actually in series on graph visualization. This one here, you just click on the tag here, and then you see all the articles. And if you scroll down, you see visualizing graphs in 3D with WebGL from a while ago, but it's still current. And so I explained here a little bit what we are doing as well. So if you rather want to read it, then you can do this as well. So I just cloned the repository, my repository, and have it here in my shell. Where's my shell? Here's my shell. Oops. Here's my shell. And I just started Python server here, simple HTTP server. So it just serves the local directory, and in the local directory we just have a bunch of HTML files, right? So and we just want to look at a bunch of all these HTML files. That's why we have code open somewhere here. Is this one? No, that's something else. Probably close. Can probably close this one here. No. Okay. So here we are. Here are in HTML files, and it basically connects to Neo4j using the Neo4j JavaScript driver that you can pull actually from an CDN, so you don't have to do anything. You can just from the front end connect directly to the database. Of course, you should be careful when you do that. You should only have read-only users on your data, and so the user that we use here, the Game of Thrones user, is actually a read-only user on this dataset. So the advantage of using this with Gephi is here you have full control over what you want to do, and you can embed it in your own application. So Gephi is a standalone visualization tool, but this one is really nice embeddable in your own application. So if you want to create your own application that visualizes some graph aspect, and it's very easy to configure and customize. And what's really nice about this library is also that he separated out the rendering from the layouting. So he currently uses either ngraph or a D3 for the layout, for the full layout, but you could also swap this out for any other layout library or your own layout algorithm as well. I think you could even make it work with, so there's like a Gephi.js version that you can use for layouting. But then the rendering then is on Canvas for 2D or on WebGL with 3D. Okay, so let's look at this. So basically we just have a really simple HTML page which just has a div for the graph. And then our script is basically just connect to Neo4j. Because it's an instance with certificates, we need to use encrypted true. And otherwise, this is our bolt URL. It's basically the same as you can see here in our database. If you say server connect, it shows us also the bolt URL. And because it's single server, we can just use bolt. We don't need to use Neo4j. Then basically after you get the connection, we create a driver. From that, and for the driver we start a session on this database, so you can select which database you want to talk to, and then it kind of starts. And it starts this way, that we just run a Cypher query, here returning the kind of relationships in the graph with a source and target node, and we just return the source and target ID as source and target from our statement, and just pass in a limit which we set to 5,000 here as an initial setting. And then with the promise, take the results, and then for the results we take the source, which is a number here. We could also have done a toString in the Cypher statement, then we wouldn't have to do the two-number thing here. And source and target. So this is our links. So it's basically a list of source target pairs is our relationships, and then basically it says how long it took to load these, and then it just puts the nodes into a set, each source and each target into a set, so we get like our unique set of nodes. So I use a JavaScript set here, and then we have basically the list of links with source and target. We have the sources, the nodes as a set, so we use array from to create an array from that set, and basically turn this into a JavaScript object with ID, which we could nowadays write like this. And we pass in the links, and this is basically our graph data that we pass to the rendering library. And then we just say force graph 3D, give us the div here, and render this data, and that's it, right? So most of the stuff here is around getting the results from Cypher and turning them into this link and node structure that we need here at the end. So we have a node is an array of objects, and links is also an array of objects where the node array has at least to have an ID, and the links have to have a source and target, right? And so if we open this, let's go to our browser. So we go just to localhost 8000. That's where Python is serving our HTML file from, and so it just fetches the stuff from the CDN, and now we already have our graph here, right? So, and if you look at the console output, we see it says loading the data across the wire 5,000 links took 1.5 seconds, right? So, and if you look at the elements, we really just have this one element which then has all the stuff in there, right? So this is our diff, and all the other things is added by the visualization library, right? Okay. So, and here what you now can do is kind of, because it's 3D, you can zoom in, you can zoom out, you can rotate it, you can pan it with control, I think it was, or something was panning. Shift was panning? No. It was panning. Huh. So something was panning, but I tried it last on a Mac, so this is like on Linux to have the streaming in order. So we get the stuff here, right? So for practical uses of graph visualizations is, of course, if you have things like, imagine you have a network management software and you want to show how people are, how devices are connected to a router, for instance, or if you have something like a fraud analytics thing where you have a transaction network of money transactions that go from A to B, then you want to have these also being, you can kind of trace these networks. So similar to what Neo4j Bloom does in visualization, you can do custom versions of them. Right? There are also some other fun examples of this. So for instance, if you look at, I did an article once, so Alberto Barabasi did an example once of mapping out galaxies. So there was like a paper from a group that mapped out the location of galaxies using force layout, and that's really cool. And so the original site is kind of Cosmic Web, which is really, really nicely done. And I just wanted to redo this myself. So Kim Albrecht did the visualization using 3JS, also unlike 3D WebGL library. And so you, for instance, can take this source data and render it as a Neo4j graph as well. Right. So so that's actually quite nice. So this graph of the universe is another example of doing that. Or if you want to visualize a ton of tweets, for instance, and seeing visually the clusters of people tweeting to each other, then you can use that as well. Right. Yeah, so I'll show you with doing the queries with the graph up in the React application. So we start with looking at the visualization options initially, and then we go for that. So here we only have nodes with ID, so there's no additional information, right? So I mean, we can drag stuff around a little bit here, and then it's relayouted, but that's about it, right? So, but we see already structures here, so you see certain clusters forming already if you look at these. So you have here cluster, and the cluster in the middle of interactions, right? So we could also, if we, because this is over all the books, so if we say we only want to have interacts 1, so if you look at the data here, you see that there's like interacts 1, 2, 3, 4, 5, and so if you only look at interacts 1, that's from the first book. So these are the interactions on the first book where the Starks were all still alive, and so if I rerun this, it should be a smaller graph, and you should also see these clusters better as well, right? So you can actually inspect this visually. So it's actually a visual help for inspecting things as such. Okay, let's look at some of the other examples. So one other thing that we can do is we can add a bit of color to this. So for instance, when we say, okay, we don't just want to return the IDs of the nodes, but we also want to return the label. So in this case, it's all the same labels, kind of a little bit pointless, and also the names as a caption. Then we just put this into the JavaScript records, basically. And so our links are still source and target ID, but our objects are basically the node is, where's it? Yeah, we just create a map by ID of the source node, and the source node has all these things, right? An ID, a label, and a caption. And then what's really cool in this library is we can just provide additional information, config information with a bunch of methods. So we can say node autocolor by label, and so if our nodes had different labels, then we would see the difference in color. We can put out the node label, so kind of the caption, where I put out like label character is this in our case, and the caption is the name. And then on hover, we can change also the style of the pointer as such, right? So if you look at this, which is color HTML, then it looks a little bit different, right? So you see that it's now bluish here. And we can also see on hover, my mouse pointer changes, and I also see the name, character, colon, and then this. So imagine we would kind of arbitrarily change the label of the target, for instance. Let's see if we take the label and we add a number, for instance, like an underscore or something like that, or the 2 here. So it's character and character 2. So that should give us 2 colors. Let's see if this does give us 2 colors in our graph. Yeah, so you see that there are some light blue nodes and some dark blue nodes. So depending on which label they have, they get a different color automatically, right? And we could do, if you added random, then it would be, so for instance, if I add a rand here, random number, then I would get just a very colorful graph, right? So then every node has a different label, basically an artificial label, and you see that we have a lot of different colors on the second node, right? The first node has still the character, and the other ones have like these weird random generated labels. So imagine you have a graph with lots of different types and labels, then you can use that to visualize these kind of graphs. Okay, so this is color. The other thing that you can do is you can render weights. This is a graph actually where we did run some graph algorithms before. Here, if you look at these nodes, they have all page rank information, and some of them also have Louvain information here, and some of the relationships also have weights. Oh no, all relationships have weights from the book. So basically saying how frequently did these people interact in the books, right? So it's kind of the sum of these interactions. And what we can do here in the weights version is that we don't just return the ID, the label, and the caption, but we can also say we return the size value, for instance, the page rank here. And we can also return the weight of the relationship. I just return the log value, the logarithmic value, because that's nicer scaled as such. And then we basically take the same stuff as we had before, but we now provide, we just want to say the node value for the size is in size, and the link width is weight, right? And because you also return the type of the relationship, so we have 4 types of relationships, as you can remember from here, right? 1, 2, 3, 4, 5. We should see these also color differently by this. So you see, by just providing one config setting here, it actually renders stuff differently, right? And that's really nice. So, and if we now load the weights version of this one, is it here? Then you should see that the nodes are differently sized. So the larger nodes are like have a higher page rank, as you can see here. So for instance, there's a larger node, which might be, this is Theon Greyjoy. Another large node is Jon Snow, of course, and another one is, so this is Stannis, Baratheon, and Tyrion should also be somewhere here. And you see the different colors of relationships because we now return all the relationships and they are colored also by color. And you also see that they are differently wide depending on the number of, the weight number that is on these relationships, right? And as the last thing I want to show you is particles, because particles is kind of a fun thing because instead of just rendering something by width, you say, I actually want to run a stream of particles from node A to node B. And you can say the weight property should give us the number of particles and also the particle speed as well. Right? So if I now render here particles, so all the other stuff is the same, right? If I render particles here, then it's actually quite a lot of data. So you see that these relationships are no longer like just lines. They're actually little dots moving around these lines. And they're actually, if it stops, let me change this to interacts. So we have fewer relationships here. What? Should be actually few. Why is it still so many? Interacts 1. Oh, sorry, interacts 1. So in book 1, so you see these are fewer, and now we see, if we go into here, we see these particles moving along the axis as well. So they should be floating along these axes. So the density, and they should actually be moving. Why are they not moving? So I have to check why they're not moving. It used to work. Particle speed, weight. Perhaps they changed something. Anyway, so these are some of the options that are possible, and as you saw in the library itself, there are a ton of options what else you can do, right? So there's examples for async loading, large graphs, arrows, we saw the particles, curved lines, auto coloring, we saw text as nodes, so you can also render text as nodes, images as nodes, controls of orbits, fly controls, camera thing, what happens when you click on a node, expanding, collapsing, and things like that. Multi-node selections, lots of stuff, right? And also other layouts as well, right? So there's a lot of stuff what you can do here. So this is kind of just to give you like a view into what's possible with this library. And what we want to do now is actually use the React version of this to create a little React app that does our querying the Neo4j graph and also render the results. Okay, and basically it's we just create a new React app, so with npx create React app, and then we just add React Force 2D as an npm dependency. So that's what I did in my console here. Let me see here. So I basically just did create React app, and then I did yarn add, and then basically just React Force Graph 2D as a dependency, right? And the Neo4j driver as well, right? I have Neo4j driver as dependency and React Force Graph 2D. So that's what I added to my React app, and then we basically can get started by just using something like this here, and component that renders some data, right? So I have my React app here in code as well. So we can close this one. And I have just the empty app here. So, and we can just say, okay, we have a Force 3D with some graph data, right? And and then we just say const data is our list of nodes and relationships. Sorry, not our list, our object. So we have nodes, which is an array of objects, ID, or we can actually use ID. We could also use name as an ID and then tell it. Let's start with this. So for instance, we have Jane and ID John, and then we can say these are our nodes, and our links are we have just one link between Jane and John, which is source is Jane. Oops. Source is Jane, and target is John. So it's basically the same structure that we created from Neo4j before, and we just pass this as data to Force Graph 3D or 2D, because we have the 2D version, right? And then if you just look at our React app, so I just run yarn run start, and then it goes. So while this is compiling, so you see it's compiling. So now we have our two nodes, Jane and John here, right? John Doe and Jane Doe, right? Connected with one relation. They don't do anything yet because we don't have any like highlighting or stuff like that. So let me just for questions, minority report, experience, exactly. So there. Cool. Let's look at how we can go, where we can go from here. So one thing we could do is we can change this ID to name, for instance. So all this stuff that we configured in the other option is also available as options for this Force 2D thing. So for instance, I can say node ID is name, and then if I rerun this, it should rerun this, and we see here now John and Jane, because it uses the name property as rendering as well, right? And if you wanted to do other things like node outer color by type, or node size, or rel size, or node val, or stuff like that, we can all do functions on node click, on node track, and so on, right? We can also provide like in width and height here. So I think that's just like something like this. And background and things like that, right? So let's see, background color is black. So if you see now the 800 by 800 thing here that we have. Okay, so now we can want to load the stuff dynamically. So we just please excuse me, of course I'm really a modern JavaScript noob. We just add a button, reload, and then we say just on click, we call a function here, reload data, right? And we just say reload data, and we just return new data here, right? So function. So we have the driver available because what I did in app.js, in index.js, I just take the Neo4j driver, create a connection to our database, and then pass this driver as a parameter to the app. And so in the app we have now the driver here as a value here. So we can just use this. So, and just to show you how to get started with this, so this doesn't use React state and stuff like that yet. So we just say driver session. So we need an async function and get a result from, we get a session. And we get a session for the database Game of Thrones. And then we say we get a result from that, which is then session run. And here's our cipher statement again. So we just do a match and then return, and in this case I just do n.name as source. Oh, let's start simple. Just let's return just n.name as ID here, right? So that's our source thing, and then we can just output what we got back here, right? So that means when I click on the reload button, we should see in the console if this was successful as a statement, the output here, right? And then here we should compare also do session close. Okay, so let's see if it compiles. I hope so. And if we reload this, we have our little reload button here on top, right? And if I click on this, it complains that that it's only a promise because I forgot the await. Right. So, oops, match, and I forgot a T in match. Okay, so if now hit reload, I see our result from the driver, from the database with 800 nodes, and each of these nodes has kind of an ID field, which is the name, right? So what we can do now is basically just say res.records.map, and from the record basically we just get the ID, right? So, and then this is our new state, right? So so if I do this again, we should see these are our nodes now, right? All these names. So how do we get this now into the object here? So we need to work with state, and this becomes funny. Let's see, can we do this set state? So I think this is where I kind of struggled initially a little bit. So what I decided is I want to move out of this app thing into a separate component. So we just say class myvis extends react.component, and we have a constructor which takes some properties which we call in super, and then we call just set this state is we have a query which is our query here, because we want to be able to edit this in the future. And the other thing that we need is kind of our graph data, right? So our data here. So, and we just use what I had here as initial data as initial state. Okay, So this is our initial state. And then we need a render function. And we return basically our stuff in here that we had in that render function. So let's see if this works. Render, return. So it's correct. I need to sneak, and then we basically just use our myvis component here and pass in the driver into this component from the app. Right, and this reload function we just also move to our component. So app is really just holding the things together here. So what I kind of struggled with a little bit with these things is I don't know what I'm doing wrong, but I always had to do the syntax and React components. Reload data is an async function that is this. Right. So, and I hope I didn't do anything wrong here. I think the only thing that I changed is this props driver, because driver we passed in as a prop here. I guess that I could also do this and call super without props, but I'm not sure if there are other props passed through, so I just do it like this. So, and I think I got the render function wrong, so I just sneak into my other thing. So render, return, curly braces. So, oh, it can't return a multi-element thing, so we need to have a diff here, I think. That was the problem. Yeah. And they used to have round parentheses here, but let's see if it works as well. Oh, and we have const data still as a remnant. So we have our tiny component now, and the app just uses the component, right? Okay, compiling. And what does it complain about? Reload data is not defined. Oh, we always need this dot something, right? This dot reload data, and here we need this this dot state dot data. So let's see. Still complain. I'm not sure if this is about round parentheses here, so I just add them for good measure. Oh, there we are. Okay, this is our component now, and if I click reload, then I see cipher query expected. So yeah, because I removed this, and this should be this.state.query, right? Because that's our cipher query. And if I reload this, I should see here my output. And this is really cool because now we can say this set state, and we want to set the data to basically nodes here, right? So that means when I click reload, it should render us 700 something nodes in this graph. But it doesn't like us. Why doesn't it like us? Records map ID to ID. Oh, sorry. We probably also have to provide links as an empty array. Okay, and I don't really like the black background here. Let me just make this, remove all these white and width and height things. So, and we click reload, and yay, a beautiful flower of nodes layouted here, right? So, and Each of those has no name because we didn't use the name thing, but ID. But we can change this really quick. I just can return here name, and then or we can keep ID here and change this to name, and then it should actually, if we do this, we should have like our name properties here rendered on our nodes. Okay, cool. So this is step number one. Step number two is, of course, we need relationships. So let me just close this here. So we need relationships. So it's not just nodes that we want, but we also want relationships. So we just add our relationship here, like interacts1 to m. And we have n.name as source and m.name as target, right? Simplest graph. And then what we need to do is get our links from the data. So basically this is becoming our source is r.source and target is r.get target. So these are our links. And now we might get duplicate nodes, which kind of is a bit annoying. So we do the same as before. We create a set. And while it's a little bit hacky, so we could also do this a second pass, but we can also just do the following. Here, for each element that we get back for the record, we do the following. We get our source here. Let source equals this, and let target equals this. So we can simplify this into like just return source comma target, right? And we can also use the source and target to add to our set source nodes at target. And so we now have a set of nodes here, and or I just call this unique nodes, and use this. So, and then our nodes is not records maps, but it is an array from unique nodes map, and we just do this is our name, and we just create this object for each node, right? So, and then we just have nodes and links as our data here. So basically, again, you can probably remove these console logs here and say, okay, just create our links, mapping the results. And while we're doing that, we also add the node names to a set. And then from that set, we just create an array where each value is an object with a name element. So we could also put all the other stuff in here, or use, as I shown before, an hash map to keep the stuff unique. That's also possible. This is just the simplest version of this. So we have this set state here, and that means now when I reload this, we should hopefully see also the relationships, right? So this is really nice, and we also have the names of the nodes here already. And so the only thing that's missing here now is the text box with the query. And this is funny because I had to figure out how to do this in React, and I was I was a little bit confused. So we have a text area here, and our value of the text area is this state query. So if you do this, we should see, hopefully, does it reload? Yeah. Oh, it complained that we don't have an on-change handler. This is in read-only field, right? So which is true. And here's our text area. We see the query in here. And if we edit this, then it does not change because it's not bound to the on-change. What I quickly want to do is here, we want to use the style. And if I'm not mistaken, we can just do width 800 pixels and height 100 pixels. So it's a little bit larger by default. Yeah, right. Yep. So this is our query, and now we have to get the editing done. And originally I tried it really naively, how I would do it in another language, but that of course led to a recursive loop. So basically what, by the way, I also learned that you have to provide the value as a value and not as a child to the text area. So what I originally tried to do is kind of something like that, on change, do something like this state, or this set state, to query is event dot target dot value. And last time I tried this, at least it complained a lot, and it just didn't work, right? Or I could also not do this dot value or something like that, right? So when I tried this, it because this dot value. When I did this, it complained about recursive changes and stuff like that. So I learned that we have to do an handle change function here, which gets an event and then basically sets the state. This sets state. So it's actually looks like the same code, but there's like React magic in there. This event, event dot target dot value, right? So we just set this here, and then we just use handle change here in this method. And you must not forget to use this, because otherwise it complains about this as well. So, and having done this, it does not complain anymore, and I can write stuff here. For instance, I can say limit 5 and reload this, and I should have a tiny graph, right? And or if I say limit 100, then I get a bigger graph. And this is my small version of an interactive Neo4j browser, where you can run this stuff interactively, and then on reload, we could also change reload, of course, to query or execute or something like that, right? Query, and then, I mean, it's not pretty, but it works, right? And if I want to get more data out of it, then I can also just remove the relationship type here. And then it's like all the books in one graph, right? And then I can start playing around with the with the, what was it called? The curved link curvature. So I can give the curvature radius of a link line link curvature 1. Let's see what happens then. If I do here link curvature 1, then where's my React app? you see that it's like this. And if I load my larger graph, then it has all these very, very curved links, right? So, and I could also say, okay, I base this on the name here, for instance, right? So, and then have kind of make sure that they don't overlap and stuff like that. So based on the type, I could have different curvatures, for instance, right? And arrow tips and like all this other stuff, right? Link, directional arrow. How we do the arrows? Okay, arrow length. And we want to have it on a target, so link direction arrow pos is 1 and length, let's say 5. Link direction arrow position is 1 and link directional arrow length is, let's say, or 10. So you can play around with all these options then, of course, and so the curvature of 1 is probably too much, so we can just say 0.5. So, and actually, come on. So you see a really nice arrow here, and if I run my query, then we see, when we zoom in, we see all these arrows here as well, right? So we can do all this fancy stuff as well. Okay, and what I wanted to say is actually this morning I started with the blank Create React app, so I didn't prepare anything yesterday or so. I just took like roughly an hour this morning of figuring out all this React stuff, which I hadn't done in a while, and I only stole the driver stuff from Bus Overflow. So we should actually also use .env to externalize the stuff into an env file and then use that. And so my component that I wrote this morning looks like this. And you see it's very similar, but now we recreated this with our own component, so from scratch. So you see that it's actually not rocket science to do something like that. Super, and that's it. And so you see in how many lines? 56 lines of code. We have a tiny Neo4j connection source browser. So if we wanted to, we could also put like the connection URL, username, password, and database into a dropdown or something like that, and then just visualize different databases if you wanted to. But I guess I'll leave this as an exercise for you as such. If you're interested, I can put this into a GitHub repo or on GitHub just because it's not so much stuff after all. And then you can play around with it yourself. Cool. That's it from me for today. I hope you really enjoyed this as much as I did, because I really like this graph visualization stuff, because honestly, I'm really bad at this myself, like everything that's like with visuals and layout and design, and I'm really grateful to Vastoriano to provide this library for us. So if you want to, you can follow him on Twitter and say thanks, because he did a really great job at putting all these things together, and really nice work. He has a ton of other graph visualization projects as well, so he's a really good guy. Okay, that's it from me, and I wish you a great day. Take care, everyone. Stay safe.